Good evening. Today we will the important and the topic for which C language is recognized. Basically, whenever somebody talks about C language or whenever someone asks you about C language, the next question is whether he has understood the pointers. I'm not I'm saying whether somebody has understood the pointer. I'm not saying intentionally whether someone mastered the pointer, because mastering pointer is no something which is always debatable. Mastering pointers is debatable, so one should not say that I have mastered. Even I do not dare to say. So there are books, there are courses, mastering pointers are like that, but one cannot. It is not that much easy, and many times, no, students are afraid about the pointers. In the interviews, vivas, questions are asked on pointers. I will try my best to simplify that, first of all. Second thing, pointers are necessary. Pointers are integral and inherent part of C language. Without pointers, it is almost impossible applications. Perhaps that is the reason Java and Python became popular, only because it is said that it is. I'm saying it is said that Java doesn't have a pointer or Python doesn't have a pointer. See, pointers are there. It is not that pointers are not there in Java or Python. Pointers are not there in Python, but they are now basically these are hidden from the programmer. That's the only case. So pointers, I think absolutely computer cannot work. That is the I mean, that is the fact. So we'll start. There are only four slides in this chapter because pointers. Today's this chapter will be just introduction to the pointers, right? Just introduction, because it's not like other chapters like loop. Though loop is taught as an independent chapter, loop is used everywhere. So while writing functions, we use the loop, we use the if else. So this is a kind of integral chapter, but at the same time, pointers will be used in each chapter after this dedicated chapter. So pointers will appear again in structures, pointers again will appear in this, again in file handling, again in string manipulation, again in dynamic memory allocation. So everywhere pointers will reappear. So what we will learn in this chapter is basics of pointers, introduction to the pointers. What is the pointer? What is the definition? How it works exactly? How the memory is allocated? What is some terminologies are associated with the pointers? How to declare the pointers? So that that aspect of pointers, that is the basics of pointers we will try to understand, right? So, what could be the terminology in this chapter? So, memory, then address, variable, data type, that is the primitive and user defined. This is the basic terminology. Our discussion will limit to this terminology only. So, first of all, memory. I have talked enough on memory. So, considering this, I will prefer to teach you using the whiteboard. So, let me share first. So I talk about the memory, right? Right. When I talk about the memory, definitely in the first chapter, if you can recall, when I talk about memory, when I mention memory, I mean RAM. And when we are C programmers, we mean data segment. So there is a data segment. Understanding memory is very important to understand pointers. Even though I have talked about memory many times, again I will cover memory aspects related with the pointer before teaching you pointer. Okay, before I start pointer. So this is the data segment, right? So this is the stack. Storage classes, I have covered all these things. This heap, this is static and global area, right? So when you declare a variable, memory is allocated. Depending upon the storage class, memory is allocated either from the stack or the static or global area. Heap we are not taking into account right now. So when I declare a variable like suppose int x, okay, or float y, or suppose character variable sch, right? So we know that whenever you declare variables, since these are we will assume that these are local variables declared inside functions. So this x will be given 4 bytes of memory, y will be given of memory, and ch will be given 1 byte of memory. All these are primary data types, if you can recall. So there are primary and there is a secondary. Primary is also called as built-in, right? Built-in, right? Or it is also called as a primitive. Called primitive. Each language has got its own set of primary and secondary. So these integer, float, character, these are primary constants in C. Now there is another set of data type which we term as a secondary, and pointer is a secondary data type. So which are secondary? So pointer is a secondary data type. Then array is a secondary data type. Structure is a secondary data type. Other are there. We will not go into the details of that. Union is there. Then type def is there. But primary data types are not sufficient as we go on developing complex applications, or somewhere just int char are not sufficient. Some other things are there which we want to store. So pointer basically is a secondary data type. It is also called as a derived data type. So pointer is basically a derived data type. Why it is derived data type? Because like int is the keyword in C, right? Float is the keyword in C. Char is the keyword in C, but pointer is not keyword in C. Pointer, when you want to create a pointer, when you want to declare a pointer, you cannot declare as you cannot declare the variable as suppose pointer. Very difficult to write on this whiteboard. Pointer PTR. It is not possible. This is not valid, right? Pointer is not a built-in data type. Create a pointer first of all, and why to create? There are many situations while writing programs, Dennis Ritchie recognized that I want to store an address of variable, right? Because pointer was made popular by C language, or my pointer was made used by Dennis Ritchie heavily to create applications. He explored the use of, rather not explored, exploited. You can say exploited. He exploited the power of pointer variable, because we know that whenever a variable is created, it is given memory, and memory has got address, right? So this this address, right? He thought of storing this address somewhere in some variable, right? So where to store that? Because storing address, you need a container, you need a variable, and he gave the name as pointer. We will say it a pointer variable when you store address of another variable, right? So a variable, suppose integer, suppose you write int x, right? So 4 bytes of memory is allocated. This will be 1 byte, 2 bytes, 4 bytes of memory is allocated, right? The name of this variable is x, right? When you store, suppose 5, right? The 5 is stored here, is stored in this. Obviously, in the of 0 and 1s, right? 5 will be stored in 4 bytes of memory. Now, what is pointer basically? Declare some variable, okay? Declare some variable in which you can store address of x, because whenever 4 bytes of memory is given, x has got some address. Suppose address of x is something like 6, 2, 1, 5, 4. This is the address. What will be address of this? Address of this, it will be 62155, right? This will be 5. Sorry, this will be 5. I will not write all 5 digits. This will be 6. Sorry, this will be 6. This will be 6. This will be 7. And this will be 8. Right? So address of this byte will be what? 621545. 62155. 62156. Right? 657 and 62158. Okay. So likewise, the address system is there. Now this 62154 is the address of the first byte of that allocated 4 bytes. This is important for us, right? This is important for us. So storing this address in some variable, storing this address in some variable, right? So this variable uh, will contain 62154, right? When you store this address of x in this variable, this becomes a pointer variable. This is a pointer. So how to declare that? In C language, you can declare pointer using the star operator. So you will use star and name of the pointer variable. Because like x, ptr is also a name of a variable, right? So how does the compiler know that this is a pointer variable? Compiler knows on the basis of this star attached to PTR. Okay. When you attach the star asterisk to a variable, okay, this becomes a pointer variable. So when you declare this, memory will be allocated. How much memory will be allocated? 4 bytes of memory. Okay, 4 bytes of memory. Listen this carefully. 4 bytes of memory is allocated. Now, pointer automatically will not contain address of X. Like other variables, pointer will also contain junk values. So it will contain some junk value. Okay, this will not be also there. So this is a pointer variable whose name is PTR. This is PTR, right? Now this will be again its own address. That might be anything. This will be having its own address because it is a memory. So whenever you declare ever, like suppose you don't store 5 in X will contain garbage. Similarly, if you don't initialize pointer, it will contain some garbage value, right? Now how to store address? Because PTR, since it is a pointer variable, it can contain address. So when you write how to store address, when you write PTR equal to, okay, I want to store address of X, ampersand X. Okay, this is the address operator where we have in the scanf function we have used that. In the scanf function you use ampersand X or ampersand Y. So you tell scanf function. What do you tell scanf function when you take input from the user? You tell scanf function whatever user is entering, store that where at the address of X. Okay, so at the address of X. This is how you tell the scanf function. Here as well, you are using the, because this is a unary operator, because it needs only one operand on the right hand side, right? So you are telling the compiler store the address of X where in the PTR. So when this statement is executed, this address will be stored here, right? So now it will contain 6215, right? And when address is stored, we say that PTR, now PTR is a pointer to X. Okay, this is very important what I am telling you. When address of X is stored in PTR, we start saying that PTR is a pointer to X because it points to the location on the basis of its contents. Okay, so how PTR will come to know where to point? On the basis of this, the contents, right? So note that when you do not initialize this pointer, it will contain some garbage. Okay, suppose there is another pointer. Suppose there is another pointer like int, right? Int star, suppose p. Okay, as soon as you declare a variable, 4 bytes of memory will be allocated. Okay, this is p. Now, obviously, like all other variables, it will contain some garbage. Okay, so suppose the garbage contains some junk value or garbage value is something like this: 42186. Okay, so what will happen on the data structure? On the data, not data structure, on the data segment. Okay, the bytes are addressed from 0 onwards, right? Likewise, this is memory. Okay. and it is like this, right? I will not draw a whole picture of that. It is like this, right? So address of this first byte, this is suppose first byte on the data segment. Its address is 0, right? The second byte, its address is 1. Third byte, address is 2, right? So likewise, the address mechanism is till the end, right? Now, when memory for the X is given, okay, so here somewhere here in the data segment, this is X, right? This is X. It has got memory, right? This is PTR, right? And this is P, right? When you store address of X in PTR, PTR will point here, right? But this P is not initialized. So P will contain some garbage. What is that garbage? 42186. So it will start pointing to memory whose address is 42186. Okay. The pointer is like that. It is as simple as it is. Right? It is called uninitialized pointer. Right? That is the reason we need to explicitly store address of one variable into another variable. At the same time, which memory to give to X, which memory to give to PTR, which memory to give to P, that is not our job. We cannot do like that. So you cannot write statement like this. You cannot write here you write PTR is equal to ampersand X, right? But you cannot write statement like PTR, okay, is equal to 6215, suppose 8, okay, or 6, whatever, or 60582, something. So this statement is not valid. What I mean, you cannot store address in it, I mean in digit format in the pointer variable. That is job of operating system. So you have to write ampersand X. This is valid, right? But you cannot write like this. This is not valid, right? Compiler will give an error, right? So this is basically a pointer. Okay. Now, I mean, smallest definition of hardest concept in computing world is of pointer. Single line definition. Pointer is a variable which contains an address of another variable. That's it. It is as simple as it is. Right? So I explained you the concept of one pointer, right? 4 bytes given to X. There is a variable int X, right? Suppose there is a variable char, C, right? To store the address of integer variable, you declare an integer pointer, right? So you wrote int star, suppose IPTR, right? IPTR. And you wrote statement like IPTR is equal to ampersand X. Okay. So there will be a PTR here, IPTR. When this statement is executed, IPTR will start pointing to X. All right. Now, when char ch variable is declared, it will take 1 byte of memory. Right? This is ch and 1 byte of memory. Right? Now, I want to store address of ch as well. So how will you declare the pointer? If you want to store address of a character variable, you have to write data type of a pointer also. It will be a char star cptr. You can give any name, cptr, right? So how many bytes will be reserved for cptr? Oh, 4 bytes. Okay, because memory is allocated not on the basis of data type. Memory is allocated on the basis of pointer, and pointer always needs 4 bytes of memory. Okay, because pointer contains an address. An address is an integer or unsigned integer. That's why 4 bytes, right? So when I write cptr equal to ampersand ch, this cptr will start pointing to this location. When this statement is executed, it will start pointing to ch, right? Now